Good morning, good afternoon, good evening, everybody. Welcome to the iDirect webinar on the rise of sovereignty. Today, we're going to be looking at how we're redefining satellite communications for national security. My name's Dave Davis. I'm the Senior Technical Director with the Global Government team here at iDirect, and I'm going to be moderating today. We are welcoming questions from you. You'll see in the console, there is a question and answer box. Please put your questions in there. We will be taking questions as we go through, and there'll be some time at the end as well, hopefully. One thing to remember is that there are some resources available in the console as well. So please have a look at that and save that for reviewing later on. So I'd like to introduce you to our two guests, Keith Blanchet and Ali Gray. So Keith is from ST Engineering iDirect and Ali is from PA Consulting. And I'll hand over to you first, Keith. I'd like you to introduce yourself and then pass to Ali, and also give us one line of what does sovereignty mean to you, because it means different things to different people. So over to you, Keith.
Thanks, Dave. Thanks, everyone, for joining here today. So, to introduce myself, yes, I'm VP of what we call Global Government, or G2 internally, for international government defense opportunities globally, outside of the US in particular. Been with the business for almost, I guess, a year and a half now, so quite new. That's the new smell in the room. But I've been in the SATCOM world for 5 or 6 years, and in the defense sector my entire career. Save a little stint into the robotics and AI world midway. So happy to be talking about this, been traveling the world, talking about sovereignty to many nations. So we'll be really looking forward to this conversation. Over to you, Ali.
Hi, so Ali Gray, PA Consulting. Perhaps I need to give you an overview, quick overview of PA Consulting, just in case you don't know. So PA Consulting is a consulting company. We are 4,000 people, about 1,000 of those do end-to-end product development. We're not a product company. But we do low TRL all the way through to high TRL product development. Why are we here? PA Consulting provides satellite communications, design, development, specification and procurement services to governments across Europe. In one particular case, we specify and design their complete end-to-end military SATCOM system. So that's PA. And then in terms of me, by the way, delightful to be here. Thank you, Dave. Thank you, Keith, for the opportunity. I've been at PA now for 3 years. I lead the satellite communications activity within the business. And prior to that, I was at Inmarsat for about 20 years. I've always had one foot in technology, product development, and then the other foot's always been in deciding where to spend money to make the best, to create the best value. So, and I'm very interested in the subjects of network hybridity, which of course, plays into this area of sovereignty. So, Dave, you asked us to define sovereignty. So let me have a go at that, and then I'll pass back to Keith to do the same. I'm actually going to be a little bit radical, and I'm going to say I want to draw a line through sovereignty, if you don't mind. I think it's a really good place to signpost this talk, because it gets everybody thinking, because it's a controversial subject. But actually, I think sovereignty itself is a slight red herring. At its most extreme, sovereignty is about having a complete end-to-end system that is designed, delivered, and operated in country. And there's so few organizations or nations that can afford to have that. So actually, I would like to cross sovereignty out and replace it with assurance and resilience. I'll leave it there. Back to you, Keith. Right.
So I essentially would answer that question, Dave, with three key bullet points. So, and it does tie into assurance. It's national resiliency. So national resiliency goes well beyond just resiliency of the network, but it has to do with supply chain and many other dimensions as to why nations go and are looking for sovereignty. I will also, the second point would be sovereign control over sovereign ownership. And Ali, you just referenced that. Historically, sovereign ownership was a way to think about it, but realistically, that just never happens, and it comes with a lot of issues and risks. So sovereign control is my second point. And the third would be sovereignty nowadays cannot exist without interoperability, which sometimes is a push and pull situation. interoperability is a must. Theaters out in the world involve alliances, and you need to be able to work with each other. So you want to be sovereign, but you also want to be interoperable. Those are the three elements I will probably underline several times in the webinar today. Back to you, Dave.
And that's a really interesting point about the interoperability. So, and obviously at the moment we're in a very dynamic sort of geopolitical stage right now. And for those that haven't picked up, that Keith is actually Canadian, and we see that the allies and the way the coalitions that traditionally, particularly in the Five Eyes community, maybe more strained. Sometimes you got that constraint of what can you do and can't you do with certain equipment, certain sort of platforms that are particularly US led that we've been used to over the last sort of like few decades. And what does it mean to you now? How are nations adapting their particularly SATCOM strategies to address the need for sovereignty in the face of those geopolitical challenges? So maybe, Ali, if you start on that one.
Sure, pleasure. So I think what's really interesting here is that all nations, most nations have some kind of collaborative alliance. And sometimes it's very tight, so we talk, for example, about a NATO first approach or Five Eyes. And that's obviously required for the smaller nations. So there's an obligation to put investment and time and build potentially collaborative systems with those allies. But what's happened over time, certainly over the last 5 years, is with the inevitable lack of trust that has come across the world, is that we're seeing nations, including those inside Europe, building their own systems as well. And I think what's interesting is that there's double the money going in, when actually we are all, as nations across the world, constrained on finances. We can't spend enough on defense. And so that really uncomfortable pull between the two means that there needs to be some solutions. And network hybridity is one of those things. I just mentioned that. There's lots of other areas, but I mentioned that, Dave, because you did, is one of the things that can bring an elegant interoperability between the things that you really want to own, so your minimum capability, and then your obligations to a broader alliance. So, Keith?
Well, there you go. I think you've covered a lot of the high-level concepts. I'll dig in a little deeper just to maybe complete the picture. So historically, we've been looking in our sovereign conversations to access to capacity. That's been at least on the ground segment, but also using the capacity that's in space. Also, historically, a lot of conversations were about, I want sovereignty, I want my satellites to be sovereign, but then the ground segment wasn't necessarily sovereign in itself. And now what we're seeing is that conversation is now space capacity also needs to be made available in a sovereign manner in the ground segment. What does that mean? That means cyber policies need to be enforced. It means the supply chain, not only for the satellite, but for the ground segment, that needs to come into play. And that now varies that industrial base requirement quite a bit. And then there's sovereign waveforms and sovereign crypto. So there's a lot of different now moving parts. So choices are being made about what needs to be truly owned and what needs to be controlled under a sovereign policy in a lot of the nations that we're engaged with now. And I'll just touch on a few key ones. I mean, we're all aware of the different natures of sovereign programs out there. There's the IRIS² program in Europe. Of course, that's a multinational approach, but then you have, even within Europe, you have the Sovereign LEO program in Germany, which is well known, and that is very specific, and they coexist. And same thing in Asia. There are programs in Korea and Japan. Even in my own country, in Canada, we have a program called Escape Polar, which is about the Arctic, which in itself is a transformation here. And now we're looking at sovereignty of its own nature, which is different from all the other ones I just mentioned in terms of how they're implemented. So as an industrial base engaging with this sovereign beast, we need to be able to adapt to the different flavors and variety of sovereign ambitions and the industrial bases in each one of these countries that can bring certain capabilities in some cases and not in other cases. So that adaptability and flexibility as a supplier, and also as a nation dealing with a sovereign problem is a must. and it's going to be part of the puzzle for, I think, years to come. But right now, it needs to be addressed now. And we need to start thinking about how these sovereign programs will be sustainable over 10, 15 years. So it's not just about being sovereign today, but it's about, because if you create a silo today, that will not be able to evolve with technology as it moves forward. Well, you'll fall behind, and I think that's key. So that's where the interoperability and collaboration across nations still needs to be part of the equation when it comes to sovereignty, in my view.
Yeah. No, really good points. And go on, Ali.
Just to add, I think what I'm seeing, which I think is very exciting for our clients, is I'm seeing a real focus on defining what they want to own and control, and actually an acknowledgement that for the things that they want to really own and control, maybe keeping up with technology, important thing. Maybe just making sure that you've got the right interfaces and open interfaces, not open from a security perspective, but open enough interfaces on those elements, and actually having a completely proprietary system that maybe even stays the same for 10 years. But then you enable your military commands, your frontline commands, to access commercial services outside of that. And those are the ones that have the enormous investments from commercial operators and indeed other governments. And you access those for everything else that isn't the golden service that you will fall back to. So just acknowledging that there's a very clear line between the two for our clients, I think, is an exciting thing.
And I think that's it with sort of particularly military leadership. People are learning the lessons from the previous war, and they're sort of like they're preparing everything and building everything around that. But then obviously that means they're completely unprepared for the next war, because inevitably things will change. So you have to be flexible enough to be able to pivot as and when you need. And I think that's a good point you're saying about the threat side of it and the threat landscape. And what we're seeing now is much more in the way of different cyber attacks at that sort of national level, but also sort of like the threats to space assets themselves. And from your perspective, so I'll sort of start with you, Ali. What do you think is the most pressing threat to satellite communications infrastructure today, and how can we mitigate against that?
Really good questions. Okay, so I can give you a long technical list if it's helpful. So there's obviously, but I'm just going to start it but not finish it. Interference is massive. Spoofing is huge, and we have to acknowledge that for most commercial satellite communication systems, they're pretty easy to interfere with. Okay, so I'm gonna leave that list behind, and maybe I'm going to ask Keith to do that, because I think he's going to do a better job than me at the sort of operational and technical risks. I like to draw out a very practical operational risk, actually, which is one of the things that we're seeing once again with multiple clients, and that is there is almost an addiction already to new low-cost, easy-access LEO services at the time of in peacetime. Now, I know it's arguable whether we're in peacetime or wartime at the moment. That's a controversial subject, but fundamentally, many are still operating as in peacetime, and starting to become addicted to high bandwidth services for general day-to-day operations. And I think, so coming back to the threat, what's the threat? So the threat there is that our people across, Army, Navy, Air Force are not operating day-to-day and being used to a wartime threat environment in their general operations. And so I think we need to acknowledge that there is a risk that if we don't think wartime all the time and prepare for it, then we will not be prepared when that big list of real threats come. I hope that makes sense, and perhaps I'll pass over to Keith to give us some of those, that long list of real threats that will push us into a wartime.
Right. So, well, I'm going to use recent events as a little bit of a proof point. So if we have a look at Ukraine, pretty much every medium of communication has been jammed in that theater, including SATCOM and So clearly the ground segment, you can have all this, and the satellites were still there. So, but the ground segment is what got jammed. So that's really, if the question was the most pressing threat. So we need to address potential cyber compromise and EW compromise of ground systems. And I would just put the line there. So what does that mean? Well, of course, jamming in Ukraine, but also we're seeing a lot of scenarios in Asia Pacific where jamming is also affecting systems. Spoofing, of course, as the RF links is something that we have to be careful about. Point of access control and trusting point of access interfaces, very key and not an easy thing to counter. We also have supply chain. So geopolitical events in the world are creating a supply chain risk, which is one of the triggers for a lot of the sovereignty programs right now, is that whole threat around supply chain and not being able to rely on having the assets that we've acquired still operate. And that's a key element. Now, of course, the space segment is still under threat. You can obviously target physically even a satellite, but there's a limit to how much you can mitigate that. So then there's the whole idea of, and that's where multi-orbit solutions come into play. Now I'm starting to venture into solutions, but having an architecture where you have what I would call a layered posture, right? So you have your hardened elements in your network, you have your zero trust style approach to segmenting threats and risks to the network. You have your encrypted traffic and your key management that could be sovereign in nature. But you also have to have agility when it comes to the spectrum, be able to go from SATCOM to other communication means, or even within the SATCOM world, vary from one orbit to another orbit potentially, and build in that layered architecture. And that's key for sovereign programs, because I mentioned this earlier. This investment is for a couple decades often. And what that means is if you're building in already from the onset a layered architecture, it's giving you options to evolve your network depending on geopolitical events, risks, and technology evolution. So very, very key elements that need to be factored in sovereign conversations, which really check all the boxes based on the conversations we're having in any part of the world right now. Back to you, Dave.
And so what part of this resilience do you think and obviously the sovereignty is one of the buzzwords that we're trying to sort of pick out and tease now. Another one that we're hearing a lot of is AI. And I know iDirect specifically have sort of like, it's a part of a bigger picture. But how do you think sort of like those newer technologies that are coming on can help us mitigate against the threat landscape?
Well, okay, so you mentioned AI, but I'm going to step back because this is essentially a field I'm pretty comfortable in, and I could go on for quite some time, but I'll keep it brief. But if you just have a look at what I just described in terms of the sovereign challenge, you can see that many orbits needing to work together across evolving technology over a long period of time, using interoperability across nations, with sovereign angles or silos of subsets of that ground network in each country. Try and manage that with a single person that's trained over, let's say, a month to monitor and manage this network. Or even if they're trained over 6 months or a year, it's too much. It's just too much. So then, now what are we talking about? Now we're talking about software-defined satellites, software-defined networks, and that opens the door to AI and machine learning and the ability now to manage and provide decision aids to users to address the complexity of the network as it becomes exponentially more complex. Now, that is today. As we move forward, technologies will evolve. Now, when we take an AI approach and a software-defined approach to the network, we're now opening the door to new, what I call edge capabilities. We have these large companies that now provide the core of the solution, but then you have agile, smaller businesses that have specialized capabilities, specialized interfaces to very specific problems that bring agility to the sovereign problem, but allow it to evolve based on very specific needs as you evolve over time. That agility is important because it allows us to adapt to the next mission. You mentioned earlier that missions today will change in the future. Well, that's key here. AI is not application specific, it's generic, right? It uses data. So when you take that approach and you bring AI into the picture with the algorithms that are not application specific, you're able to treat data and adapt it as missions evolve. And as those apps, I call them apps at the edge, evolve depending on the mission you're engaging with. So I hope that gives at least one level on the AI front, which I could go on, but I'll ask, maybe Ali has a comment on this.
Well, thank you. Sorry, you lost me for a minute there. Poor internet. Yeah, unquestionably, no doubt about it. Software-defined systems, software platforms enabled by AI and machine learning is absolutely the way forward, even just within a LEO system, let alone when you plug on GEO and MEO. So can't agree with you more. I'm going to, if we've moved on to the subject around multi-orbit constellations, maybe a couple of things to say there. One is that what's interesting in the last 5 years, we've seen consolidation across the commercial satellite communications operators. Even if they have government inputs, we've seen consolidation all around. And so that means that some of those operators have now got both LEO and GEO systems and sort of looking at MEO. So within the same operator, potentially a government client or even a commercial company can buy GEO, LEO and MEO. And it is possible for that organisation to produce quite an elegant interoperation between GEO, LEO and MEO. And in a way for the customer to get a bit stuck then with that particular individual provider across LEO, GEO, MEO. What you've described, Keith, is this open architecture where a customer can get hold of LEO, GEO, and MEO services from any operator, which of course is the ideal. Okay, I think that the easier option is going to probably to go to one commercial operator or maybe two commercial operators who have got a combination of LEO, GEO, or MEO. But I sincerely hope that we will get to the point where there is standardization across operators who and those operators are not incentivized to apply those standards. So the second point I wanted to make, which is, and I hope the client here is happy with me talking about this, but there's a really interesting piece of NATO work out at the moment. Now NATO, as we know, doesn't have any of their own satellite communication systems, so they are buying and borrowing from allies, and so the systems that they've got to set up have got to be network neutral. And I think they've got quite an interesting view about using having heavy use of software platforms to access commercial and allied operators services, and those commercial and allied operators services are going to have to comply with standards in order to operate with this alliance, and I think that's exciting. So if over the next few years we see that implemented in an elegant way, the more clients that are asking for elegant interoperation, the better services everybody will get. I hope that makes sense, Keith. So, and AI
makes a lot of sense. In fact, I love that you focused on the standards approach, which I admitted earlier is perfect. That's why we have multiple people on this. So perfect. I love the standards approach, and I just want to explain a little bit another reason why standards approach to sovereignty is key. It addresses even the geopolitical element. Right now, we have allies, we have friends. I'm from and this may be a little provocative, but I'm from a country that had very solid allies, but things change. If we take a standards approach to our architecture, we then set the stage for the ability to adapt in the future, because these standards are adopted by multiple allies. Geopolitical events can take place, but from an industrial standpoint and a collaboration standpoint, from a technology standpoint, we're still able to provide the capacity to work with each other across borders. And that's the standards approach that enables that. It requires a little bit of upfront effort, a little bit of listening and engagement upfront, but it's worth the long-term results and benefits. And I absolutely am a big fan, and we have been stating that we are big fans of investing in standards and agreeing on standards and discussing relationships around standards to safeguard ourselves from geopolitical events in the future that can change.
Yeah, no, absolutely, Keith. And I think you hit a really good point there about sort of like the data element. It's like it's only as good as the accuracy or of the data itself, and it's that you have to really make sure that you put a lot of effort into that platform initially to make sure that you're making the right decisions based on the right information there. And as I say, having that ability to flex between different systems is key. So remember, there is the question and answer box. So please put any questions you have in there. But while we're waiting for those to come in, I'd like to just pull the thread a bit more on that hybrid solutions that we touched on earlier. And how do we make sure that as nations you have the right balance between having that national sovereignty, but also enabling global seamless communications on the other side of it? And so how do you make the best choices to make sure you've got that balance right, and not just between SATCOM, but also between other potential connection methodology as well? And I'll put that one to Keith to start off with.
Thanks, Dave. So hybrid solutions are a must. I'm just going to essentially stop and say sovereignty is not just about defense. Sovereignty is about, we talked about supply chain. It's about, and national security is not just a defense thing. National security can be economic, geopolitical, and industrial base promotion standpoint. Sometimes it's about, sovereignty is about diversifying the industrial base of a nation. So the reasons that drive sovereignty vary. I just want to state that up front. But second element of this question is very important. The commercial world, if you look at the commercial world, that's evolved drastically in certain technological environments. And then the defense world is also evolving drastically in its own. So on the commercial side, we're talking about virtualization, much more software-defined capabilities. We're talking about higher volumes of nodes in the network, essentially very much software, moving towards a software environment and virtualization and a small footprint of the ability to control the network and drive and orchestrate the network. So that virtualization is taking on, it's actually spurring on SATCOM as a service capabilities and programs and a whole different commercial model even that accompanies the technology change. In parallel with this, we have the defense world that is obviously about redundancy, resiliency, encryption, security, point of access, security, data protection, and also very important. Now, if you look at both, the commercial world includes banking and key data elements. That, as we move forward and as threats to that data becomes important, will benefit from the defense advancements and port over to the commercial world. And I foresee that happening. And who knows where quantum computing will go, but that's definitely not going to make it easier. And then on the defense side, SWaP, so size, weight, and power considerations are important. And that virtualization you see from the commercial world will eventually, not immediately, but eventually also spill over into the defense world to increase SWaP and be able to put in more capacity into existing equipment and to platforms and assets that are acquired. So there's cross-pollination. In addition to all this, one of the drivers of sovereignty is control over export controls. Guess what? Now you have a dual purpose hybrid solution that is both commercial and defense. It also helps and safeguards against that. And if you use standards in the process, you're benefiting the commercial world and the defense world from those standards. So a lot of benefits of a hybrid solution approach to a sovereign problem.
Shall I add? So you asked a question there, how can you make sure that you get the right balance between assured, owned, fully controlled, let's just use the term freedom of action systems, and then other SATCOM that you might use for things that don't require freedom of action? I think that's probably what the question was. And I'm going to give a boring answer, give a boring sort of non-techie answer, and that's just to be, if there's anybody on the call here who is responsible for defining your nation's SATCOM use policy, then obviously the place to start is in use cases and look forward, the next 15, 20 years, and look at how you really want to use SATCOM and what is the absolute minimum you require. Actually, often it comes down, from what I can see, to bits and bytes, small amounts of data that are used for the most critical things, whether it be control of assets or instructions to people. And then everything else above that is a added bonus. So that would be my starting point. And then, of course, there's network hybridity that can enable elegant interoperation and access to those services. Then my second point would be just to try and simplify all this complexity and all of these technical options and what have you, is just to envisage your future control center. So if in 5 years' time, you can put in place a control center where you have a small number of operators with a number of screens that can see all of the SATCOM that you are using and its health, and be able to control and switch those SATCOM systems on or off, be able to see the threats for them. And imagine that in that network operations center, none of those comm systems could be yours. They can just be third parties. All commercial operators have network operations centers with user interfaces that describe exactly what's going on their networks. And for their most valuable customers, they port those user interfaces into their network operations centers. So I would encourage you, first of all, to think about users and your future use and what you really, really must have access to, and then think about how it's going to be controlled centrally, and then build out your system from there. So both of those are actually your end users for use of the service, and your end users for operation, and build it out. Back to you, Dave.
Sorry for this cross positioning, Ali, but I'm going to just tell you that I need to give you a demo of Intuition Foresight, because I think you may be happy to see that. But I'll leave that aside.
Okay, brilliant. Yeah, I would like to see that. I would like to see that.
And it's that single pane of glass, that single ability to control what's going on, but also going back to the automation side of it, it's that a lot of those decisions can be made automated. You set up the concept initially that if X, Y, Z happens, then you do this. You go to this orbit, this frequency, or you use X interference mitigation technique, and sort of like you can have those different layers preset. But then there's also that human in the loop that you can override that. You can make decisions based on what you're seeing. And it's important sometimes that gut feeling that really comes across as well. So we've got a question in, and this is an interesting one, actually. So this is from Alex, and it's in the context of sovereign networks. We, and I am guilty of this sometimes, tend to think sometimes of the larger nations that have massive budgets and have access to their own proprietary technology. But what happens when you've got some of the smaller nations that are relying on potentially sort of like lower budgets? They have to rely on something that's outside of their own sovereign control. How do they get access to the advanced technology without risking their own sovereignty? So I'll start with you on that one, Ali.
Yeah, good question. So risking sovereignty, I'm not sure about that, but how do you get hold of a resilient satellite communication service? I think the question is there without having to invest billions, and just like the countries that do invest billions in their own assured services and assured systems, each of those is also backing that assured system up with multiple networks. So they are actively going out, if they're sharp, they're actively going out and they're buying from all of the commercial operators. And arguably, 5 commercial operator solutions could be just as resilient as the one thing that you've built yourself. Because as long as they're operating on lots of different bands between them, so you've got bandwidth, you've got spectrum resilience there, and if they are operating from different nations and have different ground stations, and so there is resilience in diversity. So what I would say, what you shouldn't do is go and buy from one commercial operator, or if you do, go and buy from a commercial operator who has inbuilt diversity across LEO, GEO, MEO, across multiple systems, across multiple bandwidths, L-band, Ka, Ku, So rather than, if you don't have the budget to do it, to build internally, then just make sure that you buy diversity. There is one disadvantage to that. At the moment, you're probably going to have to buy 4 terminals because we don't have standardization at the ground level for end user equipment yet, but it will come.
Yeah, and I would say technologies are evolving quickly in that direction. Even at iDirect, I mean, we have multi-waveform modems that allow us to, that are embedded into a number already of terminals out there that are ESA terminals that can be used for multiple types of orbits. It's evolving. There's still work to be done on that front, absolutely, but it's evolving very quickly. And if you go to terminal providers out there right now, most of the major ones have some level of multi-orbit plan in their roadmap. And when we talked about budgets, you asked about budgets, Dave. Really, budgets varies, right? So you have, yeah, of course, massive budgets, but then there are budgets that's somewhere in between, where small sat solutions can be bundled with a ground segment offer, and this is the kind of thing that we have conversations with small sat manufacturers and operators out there that can have their sovereign wave satellite up there. We provide capacity, but then the key here is that's a single point of failure. You need that multi-orbit solution, that multi-constellation solution, that layered solution that gives you resiliency beyond just a single sovereign point of failure potentially, right? And you want to avoid that, which again brings back to interoperability across constellations and interoperability across nations, because some of those organizations that provide those other constellations are from other nations, right? Again, and that's when we talked about interoperability earlier, it's going to be a key part of sovereign conversations. So all connected, right? So all of these things are come back into a circle and are part of the conversations, which makes sovereign network conversations quite complex, and choices have to be made. What is it that we want to control? What is it we want to own? And which standards do we want to use? So 3 key questions that we need to ask to get to that national resiliency I mentioned up front. Back to you, Dave.
Yeah, and I think in an ideal world, we'd have one black box that does everything, and sort of like not those 4 or 5 terminals that Ali mentioned. And say we are getting that way with some of the software-defined networking with multiple waveforms on a single black box. But we do then have issues with the types of antenna, because an antenna is by its very nature built around a certain frequency band and a certain orbit. So this pushes us towards like a flat panel antenna, electronically steerable array, where you can have multiple frequency bands, multiple orbits being supported at the same time. But then you have a massive cost that comes with that. And again, some of the smaller nations might not necessarily be able to afford that cost. So you might end up having multiple terminals that are deployed with a single device that then combines those. And we see one of the questions we got about how is there a general standard available for satellite-based broadband, about Starlink and OneWeb and the Amazon Leo that's coming along. And actually what you will have is probably a single box that connects to multiple terminals, and then that is your one sort of unifying point. And we see that out there already, where there's some of the providers that are out there that are doing that. And actually the general standard available is IP. We work from that very base network level going forward. So I think that's going to be a really interesting time about terminals and about antennas over the next decade, of how those develop and how those get smaller, lighter, and able to use that true multi-orbit, multi-frequency capability to those at that end user. And that brings us on to sort of like some of the with the sovereign and the completely public sort of available connectivity. And that also extends out to the cloud as well, because you'll have multiple cloud providers that you'll be anchoring in, and having that software-defined networking within the cloud as well. But as far as national security goes, when we start putting these capabilities on across multiple systems, again, coming back to the what is sovereignty, how do you look at sort of like the potential localization of building these systems and controlling that, but at the same time having access to the open architectures? I mean, how do you think that's, and I'll come back to you on that one, Keith, and then see Ali and see what her thoughts are.
All right, well, I'll have a concise answer to that, and I'll leave a little bit more time to Ali because I may have spoken a little long here. So key elements, let's stick to what are the key elements. Well, there's homework that a nation needs to go through. They have to take some time and have a look at what's important to them. So I guess part of the question is what data can go in the commercial world, and that infrastructure, and what part goes to the sovereign and protected environment, and how do we distinguish that? Well, then the decisions that need to take place there are about, well, if we're talking defense and hard gov, what I call hard gov, or even soft gov, like border control and Coast Guard, you have to define what are the mission classes and what data resides in those mission classes. So there, you have to make some decisions. There has to be some policy making that happens up front. Once you know how much risk you're willing to take as a nation when it comes to which data needs to be protected, then you define where the trust boundaries are from a data perspective, but then obviously the technology that will enable that those trust boundaries. And then of course, within the protected side of those trust boundaries, then you have your crypto capability, which typically in a sovereign program will be owned by that nation. So it can be external, internal, embedded. There are many ways of going about the crypto side of things, and then the keys part of it. But that then is the next step. And then despite all of that, your system may fail. There may be issues. You may have to have fallbacks, et cetera, pace options. Then you have to think about, well, okay, how am I going to go if something fails in my protected environment? How do I fall back to my auxiliary, my contingency, and my emergency pathways on the network? And does it stay within SATCOM? Does it go beyond SATCOM into troposcatter, line of sight, other mediums of communication? And that's the next step down. So those are a lot of questions, a lot of homework has to happen before this is defined, before the technology is defined. And quite frankly, a lot of the conversations we're having at this point involves us pressing these questions and bringing them to the forefront in our conversations, because they're not always considered upfront, and that it's something that we need to, as part of the education process, which is why we're having this webinar. Over to you, Ali.
Brilliant. So there's been a few questions in the last few minutes. I'm going to pick up on one of the ones that was asked, which was around, are there standards available? It seems that everything's proprietary, and Starlink and OneWeb were cited as the proprietary systems. You're absolutely right. I can't remember the name of the person who asked that. They do appear to be proprietary, those systems, but actually each of those providers can flex quite easily. They've got, like I said already, they've got no incentive to standardize because it commoditizes each of their services. If they were standardized, we'd be into the same world as terrestrial comms, where each of the, the Vodafones and the T-Mobiles and what have you are crawling over one another to be competitive. But basically, they've got the same service. And so obviously SATCOM providers don't want that, and standardizations will bring that in. But what's super interesting is, first of all, if you've got enough money, then those operators will, for example, provide you with a lease that you can then customize into a piece of ground equipment that's yours. So there are ways around it. And perhaps more interestingly, we're seeing this this forced standardization coming into play with non-terrestrial networks or direct-to-device services, also called 3GPP non-terrestrial networks, where you have Starlink, Iridium, and Viasat, and eventually all of the major providers will be able to connect to mobile phones. And now, they are all operating on proprietary systems, more or less, but they have 80-90% of their interoperation is the same. So it is based on 4G principles or DVB-RCS2 principles that can be adapted to work with a standard mobile phone. All right, so it can be done. It's all about commercial incentivization, and the more that valuable government customers ask for standardization, the more we will see it. And I'm not plugging iDirect here, but iDirect and other organizations like them have in place already all the standards to enable all this stuff to happen. So it's a commercial challenge rather than a technical one.
No, absolutely agree, Ali. And I think it's that sort of, and we're seeing that towards the 5G non-terrestrial networking and sort of like more and more sort of coherence coming. And generally speaking, I think the satellite world has always been way behind the terrestrial world on the cellular communications, but it's getting closer, and that gap is getting acceleratingly smaller as well. So we had a really good question in from Stefan, and this one we've talked about the user terminal side, and certainly I'm guilty of sort of focusing on that element. But what about the anchor stations? Because these anchor stations have to be designed and developed to be able to support the specific system that they are anchoring. How do we provide the sovereignty there? And what are the impacts of having that balance between the sovereignty and the cost element in there as well? So I'll come back to you, Ali, on that one.
I think this is a really interesting area. So tiny little story that some on the call may be familiar with. And once again, this is all out in the open, so I can talk about it. So there has been a concept around for a while now of having anchor station or earth station as a service. Amazon put it in place probably about 10 years ago, 8 years ago now. And over time, there's been increasing interest from standard terrestrial operators to operate ground infrastructure. It's a huge cost, and it does not make any sense whatsoever for each commercial operator to have their own ground. Ideally, what we'd have is a single ground system across the whole globe, and everybody just leasing capacity. Now, recently, Eutelsat had a good go at selling off their ground infrastructure to private equity, and so that organisation then they would have leased back the services to Eutelsat, and then obviously sold those same ground station services to others. But in fact, the French government made the decision not to then send that off into the commercial world. I think that's really interesting, right? So I think for every single government, there is an opportunity to there will be more of an opportunity going forward to employ ground station as a service. If you really have no infrastructure of your own and you're not planning to build your own owned end-to-end SATCOM, then there are operators out there that can provide that. Likewise, commercial operators, some of the bigger commercial operators, are offering to governments to put dedicated ground stations in country. And of course, then there's government-owned ground stations, which are actually incredibly important because they need to be behind wires. They need to be physically protected as well as digitally protected. And any commercial operator who's providing that service needs to try and or needs to give assurances to governments that they are protecting their physical assets on the ground. Otherwise, there's a huge amount. There is an incentive for a government to run their own ground. Hope that makes sense. Both.
No, absolutely. I guess, Dave, I won't add too much to that because that covered quite a bit of ground there. But I will just say that, again, choices need to be made about what is sovereign and what is control, right? So that plays into the choices there. Multi-orbit solutions will bring in direct-to-device capabilities, and the diversity there might also enable different choices when it comes to ground stations and that architecture, because now we're talking about a variety of ways of communicating between the satellite and the users. So there's variety there. And which parts of that do you want to be sovereign owned, sovereign controlled, and how you go about that? So again, more questions. It really varies massively from country to country. So, but I think Ali already covered a lot of the ground there already. So I don't have too much to add beyond that.
Yeah, and we've got a good question in from Professor Faisal on about the affordably developing sovereign SATCOM, but about the triggering of destabilizing arms race, and actually the potential is that once everybody, if you're providing something that's sovereign and just for you, and it's better than someone else's. How do we balance that arms race, that sort of that between and again, look, there's the larger some of the organisations. We've not mentioned sort of like the Chinese capabilities and their assets as well. How do you sort of like stop that destabilization of the entire industry and the entire ecosystem? And particularly when we're looking at things like the physical threats to the satellites, potentially the Kessler effect. If you hit a one satellite, that goes on hits other satellites. How do you stop that destabilizing arms race, but still maintaining some sovereign capability as well? And I'll give that one to you, Keith, to start with.
Yeah. So standards is a good start. And if you use a standards approach to things, you're essentially agreeing with other nations that this is an approach we're going to be taking to enable certain capacities, capabilities, and then the innovations really become very more niche oriented and specific to your nation. That doesn't create an arms race per se, and you have multiple nations now collaborating and having benefit in collaborating based on those standards. So again, it's an investment upfront to engage there. And then the multi-orbit approach, right, we talked about earlier in the SATCOM specific domain, inherently involves normally in pretty much every case involves multiple nations, again, engaging and agreeing that they need to collaborate, or it actually acts as a rampart also to say, hey, if geopolitical events take place, I will then have the depth in my sovereign plan for my SATCOM network to opt for a different path and a different way of communicating and enabling my national security communications to take place. So it's a bit of a rampart against that if certain silos are created through an arms race of some sort. So those I think are two elements that came to mind up front, but it's a very good question and maybe something worth a little bit more thought, but this is my initial thoughts. Ali, what are your thoughts?
Well, I think it's a really good question. It's making me sit here and really think as well. So aligning or associating investment in space with an arms race is interesting. So I would argue that the larger investors in space are already at the point where others can't catch up. So it's not so much an arms race anymore. So if we look at the sheer capacity taken up in space by multiple commercial but US operators, and then the volume of capacity that has been secured, capacity both in orbital slots and spectrum rights, that's been secured by the Chinese, the Gawang system, it's a big volume. And actually, whilst there is lots of space up there is only so much space for LEO systems. So almost, I would say, if we're in a race for big LEO systems, there is no space for 15, 20 countries to put up their own massive LEO system. Okay, so I would say don't even begin the race. Use what's there. And be, as we've said sort of repeatedly on the call, be really clear about the things that you really need control over, which actually can be achieved by much smaller capability, still expensive, don't get me wrong, but smaller capability, and then use everything else at your disposal that's being provided by all of those organizations that are putting billions and billions and billions into, but just don't rely on it at a time of war.
Yeah, no, absolutely. I think, and it is that how much do you need and when do you need it as well? And that brings up, there's been another question in the Q&A about the encryption standards and how do you balance the domestic control and encryption when you're working with allies, but also when you might be working in a sovereign basis. And I think what we're going to see on that is an involvement of the encryption, so that you can run either your own sovereign encryption, but then you change the certificate authority or the algorithm that you can then employ another sort of like joint operation encryption as well. But this brings up the point that also about traditional encryption techniques. There is going to be that Q day, that quantum day, when traditional encryption techniques are going to be completely irrelevant, and that's somewhere between now and 2034 by most estimates. So we now need to start thinking about that post-quantum world, and sort of what do you think that how that's going to impact how we approach encryption in that sort of that post-quantum capabilities. Ali, you'd like to have a go at that one?
Yeah, sure. It's a real specialism for PA, quantum, all aspects of quantum. Not a real specialism for me, I have to admit, but certainly having a really strong understanding of the threats to the physical and digital environment, and understanding that is entirely separate to the threats to the data that goes over the pipe, and how it's encrypted is really important. And we haven't talked at all, as you say, Dave, about how you protect the data that goes over the pipe. The way that you protect the data that goes over the pipe is exactly the same as the way that you protect data that goes over a terrestrial bit of fibre, as opposed to going over satellite. So actually, we're not talking about satellite, in my view anyway. We're not talking about satellite systems now. We're just talking about general encryption. And yeah, I mean, we need to be designing for post-quantum scenarios now, and governments are designing for that. Still, the biggest weakness in cybersecurity is people, as opposed to cryptography and cracking cryptography. And actually, so in a way, I would sort of pull us back. Have I lost you again? No, I've got you. Okay, so I would pull us back actually in terms of security and cyber. I'd actually pull us back to the automation subject and usability, and thinking of security in the round, and making sure that no person physically at the edge or in the control center can put a system in danger. So that's where I place my effort, in terms of as well as making sure your cryptography is great.
Yeah, Dave, so I'll make it super quick. Agreed. We talked about AI earlier, and I'm just going to say that from an encryption and a cybersecurity perspective, AI can play a very important role in doing this, because monitoring a network with data that may be or parts of the network that are being invaded is absolutely possible for an AI engine. Very difficult for an individual. Of course, control of point of entry is key. So I agree with Ali, that is an immediate need. Moving forward, post-quantum technology will come into play, and the investments today will need to survive the next couple of decades. So that comes into that window. Flexibility and adaptability of whatever you put in the ground segment and in the space segment is key in your criteria. If you're putting together requirements for sovereign programs, make sure they're future-proof and that they have the ability to move to a software environment, virtual environment that can then adapt to those kinds of technology evolving over time, but also interface through standards to external encryption, sovereign encryption tools that may be developing also within your country. So that flexibility and adaptability is key in the design of sovereign solution. Back to you, Dave.
Yeah, no, I think that's some really good points there, and it's having that flexibility, that future-proof capability, and being able to flex between the requirements when you need that sovereign asset, but also when you don't, then being able to flex into something completely open architecture as and when. And I think we've explored some really good sort of like technologies, and also the human element in this hour, which I think has been brilliant. So thank you very much for those that did ask the questions there. I think that added a lot to the conversation. And I think really now it's just a case of wrapping up, thanking Keith and Ali for some engaging conversation there. And remember that those resources that are available via your console, and for those that haven't signed up for it already, please remember that there is the iDirect Defense Technology Day going to be in Munich on the June the 10th. So have a look at our website and you'll see details for that and how to register. And then just look for some of the links that come out after this. There will be an associated blog, a wrap up around this and some of the final thoughts, and we will look at some of the questions that haven't been answered and then potentially weave those into that blog as well. So it just leaves me to say thank you very much, and hope everyone has a good rest of the day. Thank you.
Thank you, Dave. Thank you, Anna.
Thank you again. Much appreciated.